Welcome everyone to this ENRIITC webinar. I'm going to share my screen if you give me a minute. Okay, so welcome everyone to this 6th webinar of the Enrich Your Knowledge series. I'm very happy that we have this turnout here. Some basic instructions for the webinar. Please use the question and answer box to type your questions, or the chat module if you want to comment or you want to add some feedback, which is interesting for everybody. And please note that the session is being recorded, and by remaining in the meeting, you are consenting to being recorded. We will also upload the full recording of the webinar into the ENRIITC webpage, so please be aware of this as well. So this webinar is webinar number 6 in the series of the Enrich Your Knowledge webinars. They are part of task 3.2 in ENRIITC, in which we are organizing a series of training webinars aimed at ILOs and ICOs in order to gain knowledge and learn from each other. And in this webinar, what we are going to talk about is how to, and if it is possible, to explore new avenues for ILOs. ILOs are usually heavily involved in fostering industry as a supplier in big science research infrastructures, international and national. But our activity is not so widespread, let's say, in fostering knowledge transfer and especially the use of research infrastructures by industry. And we have organized this webinar to learn about how big science infrastructures work with industry, what sectors they work with, what are their strategies, their communication channels, and so on. And we have 3 speakers. We have Giovanni from CERN, Ed Mitchell from ESRF, and Antonio Bonucci from the European XFEL. Then we will have some room for discussion, and for that we have organized 3 breakout rooms. We will try to separate people so that we have a significant number of ILOs and ICOs in each room, and then we will get back to the main room for the presentations of conclusions and some discussions. So I wanted to ask you 2 things. The first thing is, for us it would be helpful if you could change your name in Zoom, and before your name, insert the word ILO or ICO or other. For example, you can see my name. I have named myself as an ICO. To do this, you just have to click on the 3 buttons that are, the 3 dots that are on your name, that button, and click on rename. So then it will be easier to assign you to the separate rooms. And then we also have a shared Google document, which we will use in the breakout sessions. So now you will see the link in the chat, and if you could copy it and open a web browser in order to have it ready for the breakout sessions, it would be really helpful. So as you know, this webinar is part of the ENRIITC project. The ENRIITC project is a Horizon Europe CSA led by the European Spallation Source with 5 research infrastructures and 5 ILO organizations in the consortium. And what we are trying to do is build a network, a permanent network of ILOs and ICOs in order to work together across all the ESFRI domains to further strengthen collaborations between industry and RIs as a supplier, user, and co-creator. And this is part of the Enrich Your Knowledge webinars, which I mentioned before. So the overall aim of the webinar series is to share knowledge, expertise, skills, and best practices amongst ILOs and ICOs. As I said, the scope of the webinar is to explore how and what are the needs, let's say, of ILOs in order to get involved in other areas rather than industry as a supplier. So we want to learn about how big science research infrastructures work with industries in the areas of knowledge transfer and industry as a user, understand the type of industries, the sectors, and the strategies, and especially discuss, exchange our views, exchange our success stories, even our failures in these areas, and see if we could have a further role here. So just as an introduction, you know that earlier on in the ENRIITC survey, we conducted in the ENRIITC project, we conducted a survey which was sent out to ILOs and ICOs, in which we asked different questions. One of them was to rate the KPIs given by that their employers use in order to measure the performance of the ILOs. So here in the results, we can see that improving the GR return received the highest ranking as a KPI to measure the performance of ILOs, especially for ILOs employed by governmental agencies rather than public research organizations, and a little bit less for the KPI dealing with improving the supplier base for the research infrastructures. So we could see that ILOs are mostly focused on achieving GR return, as this is a mandate of our employers. But we also asked ILOs about how they rate promoting technology transfer and promoting the use of RIs by industry. And even though the scores were less than in the previous one, there is still, the KPIs reflect the importance of tapping into these areas of work. And you can see that the ratings were quite high for technology transfer and also for the promotion of RIs by industry. So these findings point us to the fact that we can evolve our tasks, let's say, as ILOs. So our speakers are Giovanni Anelli, who is the Knowledge Transfer Group Leader at CERN. Here you can see his CV. He is the head of the Knowledge Transfer Group at CERN since August 2011, and he has prior expertise with industry as well. Then we have Ed Mitchell, who is part of the ENRIITC project, and he is the head of business development at ESRF. He has extensive experience in ESRF, more than 25 years in the organization, including the project leader for the preparation of the ESRF upgrade program worth 250 million euros, and the general manager for the International Partnership for Structural Biology. And finally, our last speaker is Antonio Bonucci from the European XFEL. He is the in-kind contribution supply chain manager and industry liaison officer. Antonio also has an extensive experience in the European XFEL as well as experience in industry. And he has the double role of supporting industry as a supplier in the ESRF, but also liaising with industry for the use of the facilities. So any questions? You have my email here. Please stay tuned for next webinars. And with that, I give the floor to Giovanni for the first presentation.
Thank you very much. So let me share my screen. Do you see my slides in presentation mode?
Yes, we can see them.
Very good. So, well, thank you very much for the invitation. It's a pleasure for me to be here, and also I think it's a very interesting topic. I like very much the idea of discussing with you how we could make more synergies between the world of the ILOs and the ones of the people doing technology transfer. So I will not be very long. I will not present a lot of examples. I'm going to focus on the way we do KT at CERN, and then conclude with a few thoughts indeed about how the two worlds of procurement and knowledge transfer should not be as separated as they often are. So I think everybody probably knows CERN, but I just wanted to start mentioning what is the mission of the organization. So CERN is, as many of you know, is a very large intergovernmental organization. We receive funding from 23 member states and 8 associate member states. We have a budget of approximately 1.3 billion Swiss franc, and the primary mission of the organization is to do science. And the science we do is fundamental science. We do research in high energy physics, and I think is really basic research, and it's difficult to find more basic research than what we do at CERN, which also implies that what we do tends to be pretty far away from any market. But still, to do the research we do at CERN, we have a lot of scientists who have to develop new technologies. The innovation which we generate at CERN comes really from our own needs. So we are pushing innovation at CERN, because anytime we need to build a new detector or accelerator, we often find problems that nobody had before, and this pushes us to innovate. If we could find all what we need on the market to do the physics, we would probably do it, but this is not the case. So we develop technologies very often in collaboration with industry. There are the two pillars of the mission organization training. This is really very important for CERN. A lot of the people who come to CERN to work as students or as young graduates or not so young experienced professionals, they will not stay at CERN forever. And of course, in particular for the younger people, CERN is a fantastic opportunity to learn and to then reapply what they learn elsewhere in industry, most of the time in the member states. And then the last point is collaboration. That's really in the DNA of the organization. The way we work is, of course, collaborating with basically the whole planet. So even though we are financed by only 31 countries, there is no country in the world doing high energy physics which is not somehow connected with CERN. And the experiments are managed by very large collaborations, which are made by hundreds of institutes coming from all over the world, not only the member states. So CERN is, in this sense, very rather special place, because you really have all sorts of people coming from different parts of the world working together. So in the framework of the mission organization, we have the knowledge transfer mission of CERN. So the mission of the KT group at CERN and the CERN's KT mission, I would say, is really to try to maximize another form of return for society at large. So what we do is really for societies, not only for the member states, but of course, the way we do KT, as anyone else, involves often industry, and in this case we focus particularly on industry in the member states. But this doesn't mean that we are close to work with companies not in the member states, but all our activities in the group are primarily focusing on finding partners in the member states to help the technology transfer process. But the mission is really to show the planet that what is done at CERN, so by investing in very fundamental science like what we do here at CERN, we develop technology which are useful to everybody. The second point of our mission is promote the image of CERN as a center of excellence for technology innovation. I would say that today CERN has a pretty strong brand. Many people know CERN, but we realize that still today a lot of the people who know CERN, the majority, do not know what we do here at CERN. So they believe that all what we do at CERN is analyzing data of the experiments, but that's not the case. Actually, this is what the scientific community at large does. What we do here at CERN is really developing and maintaining a very large research infrastructure. So there is this component of being a center of excellence for technology innovation, which is not known. So the second point of our mission is to make this known to as many people as possible. And then the third point is helping the organization demonstrating the importance and the impact of investment in fundamental science. So there is, of course, we are very well aware that applied research is very important, but of course, we are also very opinionated about the fact that before applied research, you need fundamental science as well. So the game we play in the group is really to try to understand, together with all our scientists, how what we do here at CERN, which is primarily in three fields, accelerators, detectors, and computing, can help people in things which a priori have nothing to do with high energy physics. You find some areas here. Medical has always been a very important one for CERN, because there are a lot of the things that we do which find application in the field, but there is aerospace, cultural heritage, environment, and many more. Now, of course, when we speak about accelerator, detector, and computing, well, this is a relatively narrow field. If you compare it with people doing technology transfer in very large universities, where they also have biology, medicine, and all sorts of different disciplines. So we focus on those three primarily, but being let's say behind the accelerator, detector, and computing, those three words, there is indeed a lot of different sciences. So if we take accelerators, for example, you can name very ultra high vacuum, cryogenics, high field magnets, material science, and many more. And for detectors, similarly, you have material science, detectors of different kinds, electronics, etc., and computing as well. So there are quite a lot of things happening in those three fields here at CERN. So I like to spend a little bit of time on these slides because this kind of summarizes all the tools that we have prepared over the years at CERN to help the process of technology transfer. And maybe I will start with IP management. I would say this is the bread and butter of the activity of the group. We are the unit at CERN which manages the intellectual property organization. All the work which is done by our employees belongs to the organization. And so we need to understand how to eventually protect it, or in any case, how to make sure that this is exploited by others in the best possible way for their laboratory. I should say that our focus is not so much making money. So we have a little bit of revenues generated by our KT activities, which is around 2 million per year, plus minus 0.5 million, more or less. But it's not really the focus of our activities. The idea is that we really want other people to use our technologies. Now, of course, if a company is successful in using one of our technologies, we get some royalties, but that's not the primary goal. So to manage intellectual property, we of course manage the patent portfolio, which is very small. If I compare it with the KPIs that you find in other organizations, but I would say this is done on purpose. Patenting per se is not one of our goals. We really patent when we think that this helps the transfer process. In many occasions, we don't think it does, and therefore we don't spend money into a patent which might not help the technology transfer process. Then I like to move to open source because this is related to IP management, to what I was saying before. The fact that we are not focused on making money means that we have a rather open culture in the way we do KT. Well, we have an open culture at CERN per se, which comes from our convention. And in KT, we adapt to this with tools like open source software and hardware. Now, open source software is something that we use as many other organizations. There are many extremely good licenses already existing that we use happily for our software. CERN has been one of the pioneers in open hardware. We wrote a number of years ago the CERN open hardware license, which at the time was, I think, the 4th existing license in the world. And today this license is used by us, by many other institutions. Then I like to talk about funding opportunities for CERN projects. So you all know very well in our jargon that we speak about the valley of death between what we do at CERN, for example, and the market. And I would say that in our case, very often this valley of death is particularly wide. So whenever we have a technology which we think can be promising in a given application, we of course discuss it with industrial partners. In the last years, we had spent a significant amount of time in trying to get industrial partners telling us what their problems are so that we can work together with them on a real problem they have rather than trying to push our technologies out. But in many cases, what we have to sell, so to speak, is extremely early stage. And that's why we have two tools at CERN. One is the general KT fund, and then we have a budget specifically for medical applications for historical reasons. And our scientists, when they have a good technology and we have to get an idea where this could be applied and we fail to attract an industrial partner, we can finance a project which develops the technology further, but in the direction of a specific application, which is not our own needs. So support for CERN personnel. So this, I think, is extremely important. Our scientists, of course, know extremely well about the technologies. They don't necessarily know much about how those can be useful in a market. We also, of course, try to help them understanding that what is beautifully, what is technically beautiful is not necessarily valuable for an industrial partner, which might be very happy with something which is one order of magnitude less complex but is 2 orders of magnitude cheaper, for example. So we do spend a lot of time in discussing with our scientists how we work and how we can support the mean technology transfer process. For me, it's very important. I always say the technology transfer process that, I mean, our scientists do technology transfer. We support them by doing all the things that either they are not able to do or they simply shouldn't do because it's not a good use of their time. Collaboration and networks. So we are part of a large number of networks, various KT networks, of course, and we have relations with international organizations. We have all the KT which happen in EC-funded projects. I think all those activities are very useful. They tend to take a lot of time if you're not careful. So we try to use our time meaningfully in those networks. But I think the primary usefulness for us is that, of course, we discuss with people doing the same job in other places, and it's always very interesting for us to understand how people do KT in other organizations. But then the second part of this collaboration and networks part is strengthening with the member states. And here I like to mention the KT forum. So at CERN, we have the ILO forum where all the ILOs sits, but also we have a specific forum for KT. And we have KT forum representatives from member states. Many of those are ILOs and some are not. And I will conclude my presentation with a comment on this, because this is really, I think, the topic of our seminar today. Then I like to conclude briefly on speaking about entrepreneurship. So we are quite happy to work also with startups, and those can be startups which already exist, created in our member states, and they see potential usefulness in working with CERN and with the technologies that we develop here. But we also are, of course, very happy to support the people who are at CERN and leaving the organization. If they want to create a company, we want to support them. And then there are a number of activities that we do in this area. And then also events, I think, of course, for us participating to events, either organizing KT seminars at CERN for our scientists, or participate to conferences or other events is very useful to communicate about what we do and make more people aware about the possibility of working with CERN for this kind of activities. So just one word on the framework. We also have over the years developed a rather solid framework for KT activities at CERN. So we have an IP policy which was approved by Council in 2010 and reviewed in 2020. We reviewed it after 10 years because over the years we have developed a number of other policies at CERN, like one is on software dissemination. So we want to make sure that everybody at CERN understands the implications of licensing software to others and what does this mean in terms of choice of licenses, etc. We have a paper specific to medical application. We have a spin-off policy, we have a patent policy. And as I said, as we developed those policies over the years, we also reviewed our IP policy. And this is my last slide. So how can people collaborate with CERN? Of course, from a KT perspective, startups I mentioned, and then when we work with companies or other partners, we primarily work with 3 instruments. One is service and consultancy agreements. This is something we use very often. In many cases, companies are quite happy simply to be able to have the opportunity to present their problems to our scientists and get some help in the developments that they are doing. Then there is licensing. So this is typically when we have a technology ready to license, and then we license with a license agreement. And then R&D collaborations. In most of the cases, before we get to a license agreement, we go through an R&D collaboration with companies. So I think this is my slide indeed. I like to conclude just making a reflection on the link between ILOs and KT. So as I mentioned, at CERN, we have a network of KT representatives. And we leave to our member states the choice of the people who should be in this network. Some countries appoint the ILOs also as KT representatives. And some other countries keep those 2 roles distinct, and we have 2 different people. And I think this is also maybe something for the discussion. What we observe is that, well, there is no perfect solution, but each solution has pros and cons. So when the ILO is the same as the KT forum, what is good is that those people tend to know well the industry in their countries, in our fields, But what we see in KT is that the tendency that they spend most of the time doing the ILO job rather than the KT one. At least this is what they are asked to do at home. Try to have our companies selling to CERN rather than adapting our technologies. Also because the two things are not on the same time scale. Whenever we do a KT project, it normally takes years before the company is really making revenues. Some other countries keep the two roles separated, and then depending on the person that they choose for the KT forum, this might be interesting because they might take a KT professional from their country, and this is useful, of course, because then we talk to people who have the who understand our language and have the same problems. And last remark I wanted to make is that I see two avenues that should develop more in the future when we talk about KT and ILOs. One is there is a lot of knowledge transfer happening through procurement contracts. And this is something that not many people, if anyone, are good at identifying, and including CERN. So this is something that I do know, that there is a lot of very useful KT happening through procurement contract, but it's very difficult to put a little flag on it and show to the member states that also through procurement contracts, companies in the member states can get very valuable knowledge from CERN. And this is something we should be better at. And then the other comment is, I do think that procurement and KT should be somehow kept distinct, because whenever a company contacts us because they want to sell to CERN, but I think it's faster to talk to the KT people, it never leads to any good KT contract. But at the same time, I do think that there are more synergies which could be developed between procurement and KT in general in all our organizations. And that's why I think this seminar is very interesting. And I will conclude here. Thank you very much.
Thank you, Giovanni. I think it was, as you say, it was very interesting. It was on target. And I'm sure it will give food for thought for the discussion later. Nikolai raised his hand, I think. No, he was just reacting, I think. I suggest that we go on with the presentations, and then we pick up all the topics and we discuss them later in the sessions. So thank you, Giovanni, again. I hope you can hang on and take part in the parallel sessions later on.
Certainly, with pleasure. Thank you.
Great. And now I give the floor to Ed Mitchell from the ESRF.
Right. Hello, everybody. Just before I'm going to get going, right? But just to bounce back on what Giovanni was saying about the procurement angle, and I'm not going to talk about procurement at all today, but we have the same issue. The knowledge transfer, the ideas going out in procurement, it's very difficult to track. It's difficult to assess their value. Sometimes we have good ones where, for example, with AVS, a little Spanish SME, where they acquired knowledge from us about the girder supply to the ESRF. That's allowed them to do more stuff, but it's rare that we sort of see concretely the value of what's going on in procurement. Sometimes we do a little bit of tech transfer in there, like licenses and stuff like that. But anyway, not going to talk about that today. We can talk about it later. So this is going to be about the ESRF and what we do working with industry here. The ESRF, we're based in Grenoble, down in France. Very nice environment down in the mountains. I can see the mountains outside of my office window at the moment, though it's a bit cloudy today. It's not blue skies. We are, like CERN, an international organization. We have 22 partner countries. Big ones are the usual suspects: France, Germany, to the UK. We also have non-European partners, so South Africa, India, Russia, Israel are in there as well. So even though we're called the European Synchrotron, it goes beyond there. We're a user-based facility. So we don't necessarily generate lots of our own IPR, but we have a lot of users coming to use us every year. About 10,000 coming to use the ESRF or mailing in their samples, of which a significant fraction are now industrial clients or clients collaborating with academics and publishing their results as well. We've just done an upgrade, and I'm not going to talk about that, but if you want to know more about the upgrade, you can ask me whenever you want to. Right back in when the ESRF was thought about and our intergovernmental statutes were signed, they recognize that synchrotron radiation will in the future, because this was back in the 1980s, right, be of great significance in many different fields and for industrial applications. So right at the start of the ESRF back in the 80s, it was recognized that industry might be able to benefit from the synchrotron facility. So we have a sort of like a mandate to work with industry. So we're open for industry as a user, because I'm going to focus mostly on industry as a user, and accessing and exploiting the X-ray beams of the ESRF for innovation, materials characterization. And we've gone through the different phases of, well, we might be open. We're not too sure. Back in the 1990s, well, we could be open. We should be open. Our stakeholders now say we must be open. And we're actually starting to like working with industry as a user, because there's lots of barriers. It can be complicated, but we now try and make this as easy as possible. And we actually start to tailor our services to what industrial clients might want. So we're very, very much open to industry. Our missions in the business development office, so we have a small business development office at the ESRF, we've got about five permanent staff, is to do the following mission. So the provision of commercial services. So in contrast to CERN, which is very focused on the IP management. So at the ESRF, we're very much focused on industry using the facilities here, particularly related to beamline use and beam time sales for proprietary use by industry. We also do work in European grants, particularly when we're engaging with industry. And we do a little bit of exploitation of the ESRF intellectual property. And particularly this is linking to the advanced instrumentation that we design, we build, but it's very niche. And this is typically used by other synchrotron light sources around the world. And we'll come back to that a little bit later on. Why use synchrotron X-rays? Just to make sure it's clear, right? Because I mean, you can go to a hospital, people have their own synchrotron X-ray sources at home. So synchrotron X-rays are higher energy. We can penetrate large objects, look inside. We can go to very, very high resolution and look at objects as the laser. We can zoom into an object and look at very high resolution. Our kind of record, if you like, is 10 to 20 nanometers in imaging mode. This goes vastly beyond in-house X-ray sources. We've got loads of photons, so we can go super fast, look at many, many samples, like thousands of samples, which with an in-house source is just not practical. Or we can watch time-resolved phenomena, things as they change, something that's breaking, something that's cracking, something solidifying, a catalyst in action. And we can also look at chemistry, because each element has a particular X-ray signature, so we can map out where things are in a sample. And these all make a synchrotron particularly interesting to industry. Most important thing is that we can do real samples. So you can put a battery on a beamline, you can put a furnace on the beamline and watch something that's hot, watch it solidifying, watch what's going on. This is, you can see a little video here. This is very high speed radiography of a laser interacting with the powder bed in a 3D manufacturing process. So it's work by UCL and others, and they're watching here what's going on in an additive manufacturing process in order to make it better. This is work done with partner X, if you like, where we're looking at the flow of diesel in an injector. Again, we're using 2D radiography. I haven't got the film with here. But I mean, with a synchrotron, it's X-rays, man, right? So you can look inside anything. So we have a huge range of application areas. We work with archaeologists, mineralogists, drug discovery, bits of concrete, bits of people. There's any sorts of material you can put on the beamline to look at it and learn something. But when we're working with industry, we're an academic facility. So the language that we speak is completely different to the language that industry speaks. We speak synchrotron, and industry speaks some version of industry, depending on which sector they're in. So we have a big, big problem, a challenge, if you like, in the outreach, in the translation of our world to their world and their world to our world, matching what we can do with what they need, and reaching that common understanding that allows us to have a build-up of trust and an engagement with industry that allows us to provide results, data that they need. And that sometimes that sort of building up that mutual understanding can take a long time. And especially at the ESRF, we have 22 countries that we try to respond to. And that makes for a lot of potential companies and clients that we could work with. So there's a big communications and understanding challenge there. This is what we do with industry. So as I said, we can do proprietary services. Clients get their checkbooks out and they come and use us. Over the last few years, we've got about 150 clients, 35 countries around the world. We don't mind too much where the clients come from. Our mission is to help industry by providing X-ray characterization services. We work a lot with mail-in, just send us your samples, and also a la carte, sort of like really tailored designed experiments. And of course, clients can we can do a little feasibility access, like sort of a little test before you actually go in and jump in. Industry can also access us through public access. The only rule here is you have to publish the results and the data. So that's not always appropriate for industry, but we're very open and welcome industry if they come through the public access system. It takes a bit of time though. It takes about 6 to 9 months to get the access to the beamlines. Over here, we do it as fast as we can. Our record, I think, is the day after being contacted, but that's quite rare. Collaboration grants, we do a lot of work there. Tech transfer, we have about 30 technologies currently licensed or has been licensed, about 35 now actually, that have been licensed in the history of the ESRF to various different companies. We do a lot of in-house manufacturing. So some products we actually manufacture and sell ourselves directly, where we've got the production capacity, the labs that can do that. So we have, for example, X-ray scintillators or X-ray crystal analyzers that we make in series, and we've sold many hundreds of those different products. So we do have a metric. There is a focus a little bit on cash. So our stakeholders, the member states, in 2016 set an annual income target for the ESRF. Cash income, so not grants, not collaborations with industry, but cold hard services or tech transfer. And that was 1.6 million euros at the time. And it's been growing by 5% ever since then. And this year it's 2.3 million euros, and it's growing 5% on from here on. So that is quite a challenge. And I was originally a bit worried when this was set, but we can discuss it later, but it's actually been quite a positive thing because it really puts the industrial income, the collaboration, the partnership with industry really on the map as a core mission of what we're trying to do at the ESRF. There's a lot over in public access that we're not really aware of the engagement with industry. It's often the case that an academic might be working in partnership with industry, but the industrial partner's not shown on the application for a variety of historical reasons or whatever it might be. And it would be nice to have more visibility on what the industrial engagement is here. Again, we don't mind about it. It's just, it would be nice to know more about what is going on there. I wanted to give a flavor of some of the things we do try to do in communications and working with industry. Of course, since COVID, we've focused a lot more on webinars and electronic and digital outreach. This is from, I think, from 2017. I've got rid of the year. This is just some example of some of the outreach we did during the year in going to conferences, either academic or industrial or mixed, and going out trying to spread the message about what a synchrotron is, what we can do, trying to teach and train industry into the things we can do. We go out a lot to brokerage meetings, B2B. That's just last week, we were at the Rendezvous Carnot in France. Again, it's an annual event. And earlier that week, we were at Tech Connect in Sweden. These are the first events we've actually been doing. This week, we're at a French X-ray meeting. Next week, we're at the battery show in Stuttgart to show off what we can do with batteries on the Grenoble Innovation Campus, including synchrotrons and neutrons. We also sometimes organize our own events in training or outreach as to what we can try to do. And the best way, like the royal way of engaging is to have company visits, one-to-one, going out to the company or having companies visit us on the site here. And that's really where you can engage and build a relationship with an industrial researcher to understand what they want and how perhaps we can help. It does work sometimes. Is the video going to work? Hang on, I have to stop the laser, I think. It'll work. Okay, I give up. This would be a video of a beamline operating manually. AstraZeneca is a big pharma company, and they've been working with us for a long, long time, and other light sources in Europe. They use us for drug discovery. We provide protein crystal diffraction data on a very regular basis to AstraZeneca. And it's got to the level of trust that they've felt able to throw away their in-house X-ray source. They used to have an in-house X-ray source where they collected some data, and then they gave us some crystals together with Max4 and other facilities to collect data at the synchrotron. But they've now got to the level where, okay, actually we get better data, it's more effective and efficient to use a synchrotron. And there's enough trust that they now have chucked that out, and they exclusively rely on synchrotron data coming in every few weeks with their protein crystals, and they rely on this for drug discovery and for their combinatorial chemistry and other pipelines in-house. But that has taken a long time. It's a shame you can't see the video, with some specific equipment, with robots, sample holders, barcodes, secure access, secure databases to build that up. And both academics and industrials now use those processes. But it took a long time. There we go. We use some of the European projects. Streamliner is a European project to specifically tailor services. So Streamline is an S3 project we've got going at the moment with 5 million euros just for the ESRF. And in there, we've got an industrial work package where we're working with BASF is one example to build a tailored service for X-ray powder diffraction. So high throughput, aiming at thousands of samples eventually, and just going through our beam lines, going pang, 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 right, at that kind of speed, with data being collected and being able to be delivered back to the client. So BASF is being very open with this on this, and it's Bernd Hendrickson who's being absolutely superb. And we're using BASF as a sounding board for what they need in such a service, so it matches with what their requirements are, how it streams into their in-house systems for the data to be used, so that it's tailored and matching what industry needs, not what academics needs, but what industry needs. And in here we have money to have people doing the programming, the software, designing sample holders, and like doing the engineering behind the service that we want to put in place. And this kind of win-win format, this is Magnus. Magnus is like me, but at Max 4. And one comment at Tech Connect last week, he said, well, you know, we really need to be not static on the synchrotrons. We need to develop and fit the needs of industry. So to tailor the light source to what industry wants. It's not industry tailoring themselves to us, it's us tailoring ourselves to what industry need. IRT NanoElec is a French grant focused on nanoelectronics, and here we had capital money and resources for staff to help build, again, a dedicated setup, in this case focusing on nanoelectronics for topography on one of our beam lines. So topography is used for looking at crystal defects. So here now we have a routine service that's actually quite popular, looking at defects in materials that are important for the semiconductor industry. And that works very, very well. But we couldn't have done that without the investment from, in this case, the French government in the IRT NanoElec. We're increasingly seeing an ecosystem building up around the light sources. We have that's not supposed to be SMEs that have built up a mediator network where they have a niche environment and they bridge between our world and the industrial world. So they allow that translation to happen. So for example, in Grenoble, we have Novitom, who specialize largely in tomography, but other techniques as well. And there's people like Finden, who specialize in X-ray spectroscopy and catalysis, and they help bridge the industry to us, and they can translate the data, they can design the experiment, they do the access, and then they provide the service to the companies. And there's got to be at least 10 to 20 of these kinds of companies now around Europe. We also have the RTOs. Right? The RTOs around Europe, these are just a few examples. There's obviously very, very many. DTI, Nikolai and others, RISE in Sweden, Fraunhofer's in Germany, the CEA in France. And these are increasingly having a very high profile and important role in as a multiplier. These all have very mature and rich industry networks. And we work a lot with CEA now. They're a partner in the IRT NanoElec as well. We see Fraunhofer, we see DTI, we see RISE, all using the ESRF and other light sources, neutron sources around Europe, and partnering with industry to provide the added value service. And this is something we'd like to see more of, working with such RTOs around Europe. We do a little bit of knowledge and tech transfer. Ceph Technology is an SME based, if I remember correctly, down in Toulouse in France. We've actually sold them a magnetic measurement bench, and this is quite a big thing, and it's used for magnet shimming on magnets that CERN or the ESRF or others might use. And they've bought a bench from us. It's a 6-figure sum. They've used a bank loan and grants from the region down there to buy it. It's quite a considerable investment for Ceph Tech, but it's allowing them to add a service to their offer, their commercial offer, and it allows them to expand their business. Which for us is a very nice and elegant sort of knowledge and technology transfer story with a French SME, and it's elegant that this company is adding in some of our design technology to their service offering, and we are about to deliver the magnet. It's quite a big thing, right? We're about to deliver that just before Christmas this year, and then Ceph Tech are actually going to build the room around where it's going to be delivered, because it's otherwise they can't actually get it into the right space. I'm nearly done. I just wanted to, some quick advertisement. SMEs are a politically important and innovation-rich target, if you like, for helping support their competitivity and their innovation. And we have a new scheme that's built on one that we've had running for a few years, where we have subsidized access for SMEs with European money. In this case, it's from the Leaps Innovation Project. And with this, we can, it says opening soon, it's actually open now if you go and have a look. With this, SMEs can put in a very simple and very fast application. We try to respond as quickly as we can to have access to the light sources. We're not talking about mega access for very big projects, but for like a tomography or a powder diffraction or a protein project, they can have access. And the key thing is here, that of course, is the European rules allow the SMEs to keep the data confidential and to have the results kept for themselves. The IPR belongs to them. We can't do this with big companies, it only works with SMEs, so that this is open. And as I said, it builds on a previous experience we had. We had 10 SMEs using the ESRF under the scheme of Calypso Plus. And these are 3 examples from this year, just before the Calypso Plus scheme finished. We had Takis Biotech from Italy, small company there. They were doing protein crystallography on COVID relevant samples. Scandiflash from Sweden came to us, and they wanted to collect some effectively reference data to use from the ESRF against their own home-based X-ray detector system. And Hey Planet from Denmark came over, and they did for us a very simple micro CT on insect-derived food ingredients to look at the kind of the structure of the food ingredients. So often these are quite simple experiments for us to do, but they're quite important and very useful for the SME concerned. So I hope in the new scheme we'll have many SMEs coming to use this. This is the last but one. We've recently made a little brochure on the ESRF impact on industry, covering industry as a user, as a supplier, as a collaborator. You can go and look at the web link here and get the PDF if you want to. This is one example with Prior PLM. It's an SME in Ireland, and they used us to help improve inhalers. It's probably not going to show up in the background. The inhalers, these things, you know, if you've got asthma. And here they wanted to understand how to improve inhalers for their clients. They did some very beautiful high-speed radiography. You can read more about it if you want to in the brochure. And I think that's it. I don't do this on my own, of course. There's a team in the BDO, plus there's legal and contracts and the Beamline staff that help us do this. This is obviously before COVID times, down at the chalet on our site that came from the Czech Republic on a very big lorry. And that's that. Thank you for your attention.
Thank you. It was very interesting. I think we learned a lot of things. And now we go for Antonio Bonucci from the European XFEL. So Antonio, now the floor is yours.
Yes, thank you very much to invite me. This is my presentation, and could you see it? I'm Antonio Bonucci from European XFEL. First of all, I'm in kind contribution supply chain manager for the construction that still has some area not closed, but from documentation point of view. And I'm European XFEL Industrial Liaison Office, that is equivalent in your language like ICO. In our official document, we distinguish ICO like European Industrial Liaison Office and the ILO like National Industrial Liaison Office. What is a European XFEL, for who of you doesn't know? It's really a new facility, I would say, because we started in 2017 in Hamburg, based in Hamburg. We have more than 400 employees. It's international facilities, so selected all over the world. And yeah, the property, our shareholder, like ESRF CERN, is really international with the 12 partner countries. I will go quite fast on the general presentation, but essentially the FEL try to measure, characterize samples using its property and trying to achieve atomic resolution in the spatial observation of the sample, and thanks to the ultra short flashes to observe till microsecond, millisecond, and perhaps also low the biochemical reactions. And also we are able to observe single molecules. These are the insights from academic and industrial point of view. We are young, but already we had, this is not updated because we arrived to 2020, more than 1,000 users, 95 experiments. We started immediately with external user because we are user-driven like ESRF. And we are starting to accumulate a very big quantity of data because the file, because of the resolution of the file, we must work with the big data, and the forecast is higher and higher. This is the facility that is a linear topological point of view, but here already there is something relating to my activity. You have the injector, the superconducting linear accelerator, the ondulators, and after the area of the experiment, the so-called experimental hall with hatches. But even everything is our ownership. At the end, we subcontract the operation of the accelerator to DAISY, that is our first agency representing the shareholder, but also our first cooperator. And then all this area is out of our interest from the point of view of the ICO and also for, of course, the technology transfer. On the contrary, our expertise are in the hatches and on the photon tunnel. So our talent is really at the experimental side and also on the photon side. So where we develop something in terms of innovation. What my European XFEL ILO is doing at European XFEL? Well, we make three things that seems a little bit far away from them, but at the end, as I will show, are really connecting, and it's related also on my proposal, why not, for the national ILO. First of all, we support the acquisition phase before and after the procurement. Before, we support our staff with technology survey, and I will explain that the national ILO from this year are really supporting us in this kind of activities. And the goal is essentially to enlarge the pools of tender and to promote industrial collaboration, but also to minimize entry barriers, to avoid that at our call for tender or our collaboration, only industry that are very expert to apply for a tender, call for tender, are winning. So we want really the merit as first goal. After, I'm working a sort of industrial user office that is trying to promote the access to the industry, to our experimental program, but also to our lab facilities. And I'm taking care also of knowledge transfer and technology transfer. Why all these things? Because actually the ecosystem of companies that create trust and long-term relationship that are important for all these topics are in such a way between all three, the intersection of three. It's really an ecosystem. And then, of course, like daily activities for minimizing entry barriers for industrial suppliers, we make, as I told, technology market survey, promotion and information, because unfortunately we are not like CERN and ESRF. European XFEL is less known also from our supplier. As access of industry experimental program, we take care of industrial user, and as I use the word knowledge exchange, and after I will explain why, knowledge exchange and technology transfer, I make a work as innovation manager. Of course, I take care of possible intellectual property in the future license agreement, and also industry sponsor research. But what is very important as a topic now for our companies to promote really internally the innovation. And I'm practically speaking supporting any kind of development that is innovative. For instance, we have a program of R&D projects, and then we select the few ones that has innovative content, and we support the staff even with the third-party funding that are really important to arrive, but also in the generation of the partnership both with company and academy to achieve the challenging goal. And then this is the typical activity of ILO, like different institutions are telling. So here in the center, you see the activity of procurement, where it's only procurement and we are completely out, because there is all the administrative activity related to the regulation of the call for tender or other kind of approach to the procurement. And we are before, a lot of time before, when the staff is even in conceptual design, supporting them to compare different technology and consider different technology in their development. To improve, of course, it's not only to look for other company product, but also to compare other possibility, because there is some benefit to evaluate technology that has also a future, because some technology that someone knows can be also obsolete and cannot have a future for development because it's missing the complete ecosystem related. And after, so we are starting to make a process, but I'm already involved in different projects in this area after the procurement. So in the kickoff meeting, probably I will be more and more involved, not all of them, of course, but the most innovative one. And in the relationship with the industry, in particular, in the development and the amendments of the contracts, and also to look for missing technology competence during the activities that can have some support from other companies. Here, the national, why I'm doing this job? Well, in the in-kind contribution that I will not describe, I did, practically speaking, the same, from the expression of interest of some institute till the very final success deliverable. I follow all the process of development, in particular for cutting-edge components. Then the national ILO, so your ILO and the ILO of our shareholder are involved to support this phase of technology market, to find technology provider, alternative technology provider, but also, of course, they are informed for call for tender like anyone else, but they receive, of course, the information. And also we ask them for a company that can provide some even not only technology, but some solution for tender lower than the threshold, European threshold. In any case, here you can see how many institutes participate to the construction of European X-File. Why I'm showing this? Because during the construction, we didn't have any IP. So all the IP was shared, the ownership of the IP was for the institute and the company that participated and contributed to our construction. And that was working very well. But during the operation, we start now, thanks also to the generation of this new office in the company, to generate also our intellectual property. But coming back for what Giovanni and also had told before, now there is a lot of interest instead to develop the internal intellectual property co-owned with our industrial collaborator. That could be industrial collaborator during procurement, but also during so-called industrial collaboration that are also legal definition that are out of the procurement rules, or even in third-part funding consortia that I'm really promoting when we want to develop innovative ideas. And then my idea is, but this is a personal idea, still not proposed even to our ILO, that in general, if there is this kind of activities, the national ILO could also support not only to find technology provider, but perhaps notify us third-part funding for industrial collaboration. That could be a way for this kind of development, for instance, at the national level, more than European one, or bilateral collaboration between state, particularly in our case, Germany, since we are a GmbH. Probably during the phase of the development, They can help us, of course, with training of course, for the participation, our procurement policy. Also, there is a topic of CE mark and safety requirements. This is quite important, but this is not about innovation, but probably they can also help us for alternative technology provider when we found some missing competence at technology level in our development. And why not? Also, company interested in the exploitation of our technology. Since for our convention that is public, we don't have a fair return for the procurement, but there is actually a fair return for the technology transfer, in particular with more better condition in case of technology transfer. So it's also in the interest of the shareholder. About industrial user, I showed few slides still, so this is perhaps not very suitable, but it's used, a slide that it is used in the presentation of European FEL to compare FEL with the synchrotron. It seems that we are following more law when we talk about brilliance. I can compare European FEL with other facility FEL. We are still the first in terms of electron energy, wavelength range, brilliance, and so on. But this means that we are the really state-of-art facility, but we have not so many hatches still available. We have only 6, so our beamline time is really limited with respect to the synchrotron. But what is really important is that we are starting, and then we are not able to make any measurements. And if you have a new user, we are not like a synchrotron. You have to make developments. And this is a very big difference with respect to the synchrotron. We are not able to offer a service. So it cannot be that the company is coming to us with a sample and we will give them the data. Moreover, when expert users of synchrotron are coming to us, they are lost. So everything, they have to learn everything from beginning. But this is for me, instead, that a problem as always an opportunity, because perhaps our industrial user, like always in the first number of industrial users that we have, are really industrial collaborators. And in my opinion, the best model that is working is that they are working with expert user of FEL, and probably they can help us to create a new analytical method that are useful for applied science in terms of industrial collaboration, 100%, with associated probably covenant IP or other similar topic, if it's the case. And then probably the potential national ILO support in this model could be from one part, of course, always they are more informed about national or third part funding suggestion and help in this sense, but in particular to look for contacts of potential new expert user, so research and technology organization, and say that are more similar to applied science to create this nice cycle of connection to industry. Then these are my conclusion. For me, the industrial network with the national ILO are extremely important. And this year that I'm involving more and more in the first topic, that is the ICO topic, it's really showing how very important resources for our facilities are, at least for European FEL. Now they are involved, I would say, before and after the before the procurement process. Still, there is not still an involvement afterwards. But in my opinion, they should be involved in other activities. Of course, in the training, we talk about also the different language, so in such a way they can understand why the facility needs all this bureaucracy, they call it, about the procurement law that is actually regulation, normally regulation. But perhaps they can also, and it's happening, I would say, suggest expert user in industrial collaboration, and also third part funding, and in exploitation phase of the IP, looking for interested companies. So this is what I thought could be useful for the discussion afterwards.
Thank you, Antonio. Thank you very much for the presentation. I would like to thank everyone for this interesting conversation, the ideas that came out. Of course, the speakers, Giovanni, Ed, and Antonio, and all the staff of the ENRIITC project for the support, Madison and Charlotte. Don't forget to fill in the survey. Once you disconnect from the meeting, a survey will pop up, and we need you to fill it in for the reporting and to the European Commission. So please fill it in. And if you have ideas for further webinars or meetings, we are open to your information. Everybody, goodbye.
Thank you very much.
Thank you. Bye-bye. Ciao.
Thank you.